Okay, so in this here, I'm just gonna do the precise definition of a limit and just show that the following. How do you prove that exactly this limit will be equals to minus 3, and this one the limit will be equals to 6, and then this one the limit will be equals to 0, and this one. So whenever you are dealing with the precise definition of a limit, you are given that you have epsilon greater than 0, and you want to find delta greater than 0, such that such that the absolute value of x minus a. Remember, basically this comes from whatever you have. Basically here a will be equals to 2, here a will be 4, and stuff, progressing like that. Then we have this implies that the absolute value of f of x will just be your function here minus l, and where l is just technically the limit value that you get, and then this will be less than epsilon. So this is basically what you have to do, which makes it simple because you're basically having this. So now let's try the first one. So now the first one, it says let me just go here. The first one, it says that limit when x goes to 2 of 2x minus 7 equals minus 3. And whenever you do this thing, this is your first statement. Whenever you do proofs, you first write this statement. I'm just not going to do it because it's just going to waste my time. But whenever you do this, this is your first statement, and then you just plug everything in. Then you have 0 is less than the absolute value of x minus 2 is less than epsilon, I mean delta. This will imply that your f of x is 2x minus 7, and then the limit value will technically be minus 3, and then you want to show that this relationship is valid. And then simplify here, you get 2x minus 7 plus 3 less than epsilon. Then further simplify, you get 2x minus 7 plus 3, that's just going to give us minus 4. And then you have something like this, less than epsilon. And then what you're going to have, you can factor by 2 here. Then you actually take the 2 outside the absolute value since it's already positive. Then you have something like this. And then that means you're going to have x minus 2. The absolute value of that will be less than epsilon over 2. So that's what you're going to have. And then you're going to choose delta equals epsilon over 2. And now you want to verify if 0 is less than the absolute value of x minus 2 is less than delta. We'll actually use this, but it's technically simplified up to this version here. So you have 2x minus 7 plus 3 is less than, this will technically be equals to 2x plus minus 4, and this will be equals to 2 into the absolute value of x minus 2, and this will be less than 2 delta. This will be less than 2 delta because you just have 2, and the absolute value of x minus 2 is less than delta. Then you're just gonna have less than 2 delta. This 2 is the one that's here. And then what is delta? Delta is equals to epsilon over 2. So then you have epsilon over 2 times 2. That's just gonna be epsilon. Then you just verify that one. So this will be the proof of the first one. And for the second one, you're just gonna have the limit. This one is a much complex one. The linear ones are technically simple, so you shouldn't be able to not get the linear ones. And then now the second one, it's x squared minus 10 equals 6. X squared minus 10 equals 6 here. We want to prove this limit. Now I said the first thing you write is this one, then you just plug in, but I'm just not gonna write it. But whenever you do your proofs, write them. Then you have x minus 4, the absolute value of that less than delta. This will imply that the absolute value of f of x, which is just x squared minus 10, minus the limit value, and the limit value is just 6, and this will be less than epsilon. So let's look at this. So we have x squared minus 16 if you simplify that. And then what you have here, you have x squared minus 16. Can we factor this? This will technically be the same as x minus 4 multiplied by x plus 4. Difference between two squares, this one. And then you can break it down into the absolute values. Then you have the absolute value of x plus 4 multiplied by the absolute value of x minus 4 less than epsilon. Now, notice that we have a problem here with this x plus 4, and we need to take care of it. So now we can actually choose something close to our limit value here. And the limit value is technically 4, right? And then if we plug in a number here close to 4, let's say we plug in 3, we know that 3 is close to 4. 3 minus 4, that's minus 1. And the absolute value of that is going to be 1. So we can technically choose delta equals 1. If we choose delta equals 1, then we have 0 less than the absolute value of x minus 4 is less than 1. then this technically implies that x minus 4 is between minus 1 and 1. This is just the rules of inequalities. I think you're familiar with them. But now we are trying to obtain x plus 4. If we are trying to obtain x plus 4 here, we'll have to add 8 on every side here. If we add 8 on everything, then we'll obtain x plus 4 here. Then we have x plus 4. 1 plus 8, that's 9. Minus 1 plus 8, that's going to be 7. Then we obtain something like this. And then the absolute value of x plus 4 will be between the absolute value of 7. The absolute value of 7 is 7. The absolute value of 9 is 9. And be careful on these things, because like you can technically tell 7 is less than 9. So don't end up mixing things here on this one. Then from here then we can now replace this x plus 4 with this value here. So then we technically have 9 into the absolute value of x minus 4 is less than epsilon. And then the absolute value of x minus 4 will be less than epsilon over 9. And then we choose, from here we can choose delta minimum. Delta will be equals a minimum. Then the first value right here is the value substituted in. I substituted in 1. And the upper value will be the one that you have here, which is just going to be epsilon over 9. And now, remember, you need to verify. To verify that 0 is between the absolute value of x minus 4 is less than, the absolute value of x minus 4 is between 0 and delta there. We need to go back to our function, which is just the square root, the absolute value of x squared minus 16. And this will technically be the absolute value of x plus 4 multiplied by the absolute value of x minus 4. And this will be less than 9 delta, and this will be equals to epsilon. And then you have verified. And technically, like whenever you are done here, if you verify your thing, let me go back to the first example. If you verify this thing, you can then conclude, therefore, by the precise definition of a limit, then you rewrite that this statement holds true. And you can also do the same for this one. I don't necessarily need to show everything, but I'm just telling you that it's right to write your conclusions to your work. Now, if we look at number 3, it's just going to be a similar example as well. And then let me just do number 3, and then you can try number 4 on your own. And then number 3, we want to show that 0 less than x minus 1, the absolute value of x minus 1 is greater than 0 but less than delta, will imply that our function is just 1 over x minus 1, and the limit value is just going to be 0 there, and this will be less than epsilon. And now if we consider this side, you're just going to have 1 over x minus 1. The 0 will not have any effect on that. And then 1 times x, that's x. 1 minus x cannot be simplified, so we're just going to leave it as it is like this. And then this is less than epsilon like this. And then notice here we have x minus 1, but here we have 1 minus x. What do? We're going to have minus into x minus 1 like this inside the absolute value. Then we can take the 1 over x outside. So then we have something like this. I apologize for this writing. Let me just rewrite this. 1 over the absolute value of 1 over x multiplied by the absolute value of negative into x minus 1. This will be less than epsilon like this. And we know that the negative is just basically going to fall away since it's just the absolute value. Then you just technically have something like this. But now again we have a problem there, 1 over x. That's why I was like saying that for the linear case it's technically going to be the simplest, because for this one is technically you don't need to have multiple epsilon delta substitutions. So here we can choose delta equals, now let's go back. We want the answer to be closest to 1 as possible. What x value can we substitute in? If we substitute in 0, then we have minus 1. The absolute value of minus 1 will be 1. And then choose delta equals 1. Then when we do that, then you have 0 less than the absolute value of x minus 1 less than 1. And then this basically means x minus 1 is between minus 1 and 1. Now to obtain, now we just need x, right? We just need x. That means we add 1 on everything. When we add 1 over everything, then here we technically want to have a problem, since we're going to have 0 and we need to reciprocate that. So let's change our choice. Let's say we plug in x equals half, and that way we can choose delta equals half. And then we have half here, and then we have minus half and half like this. Then we add 1 on both sides, then you're just going to have half less than x less than 3 over 2. 1 plus half is going to be 3 over 2. Then you reciprocate. And when you reciprocate, you're basically going to switch this 2 and then you reciprocate. So you're going to have 1 over x between the reciprocal of half is going to be 2. The reciprocal of 3 over 2 is going to be 2/3. Then you have something like this. And then the absolute value of 1 over x will lie between the absolute value of 2/3 is going to be 2/3 and the absolute value of 2 is just 2. Then you have something like this. And then you can plug in 2 here. You can plug in 2. Then you have 2 multiplied by the absolute value of x minus 1 is less than epsilon. Then the absolute value of x minus 1 is going to be less than epsilon over 2. And then when you have something like this now, you can choose delta, have a minimum of, what did we plug in? We plugged in half. Then when we plug in half here, and then the upper value will just be epsilon over 2. Epsilon over 2. And then from then you can just verify. And now to verify, we're going to have, let me just write it here. To verify, you know that part, you just write this to verify, but instead you're just going to have x minus 1 less than delta. And to verify that, we're just going to choose this function as itself. Then it's 1 over x minus 1, and this will be equals to the absolute value of 1 over x multiplied by the absolute value of x minus 1. And this will be less than 2 delta. Less than 2 delta. Because like the absolute value of 1 over x is less than 2, then this one will just be less than 2 delta. Notice that I just plug in the upper value here. And then 2 delta will be equals to delta equals epsilon over 2. If you keep that in mind. And then this means that this one will just be equals to epsilon. Since delta is equals to epsilon over 2 from here, we can basically check that. And also on your choice of option. And then that's your verification, and therefore you can conclude by the precise definition of a limit. Therefore, the limit when x goes to 1 of 1 over x minus 1 equals 0. So that's just the precise definition of a limit. And you can also try this one. It's not that hard. Same approach.